The second equation of motion is useful for finding your position, but not just your displacement. I'm not talking about your displacement. I'm talking about your initial or your ending position, your final position or your initial position. All right. And so we found average position, that's called displacement. And now we're going to look at how do we manipulate it to get my, maybe my final position or my initial position. In this case, we're going to stop at final. All right, so we're going to start with how do we get this? How do we get this particular equation here? Well, if I wanted to find my change in position, I can take my final position and I can subtract my initial position, right? Well, if I wanted to get final by itself, I'm just going to add this guy over. And so my final position is the same thing as taking my initial and adding to it how it changed. Doesn't that make sense? My initial velocity, my initial position plus how my position changed should be my final position. That makes sense, right? And so we start with this guy. And what we're going to do is we're going to go through and we are going to use what we used before to kind of manipulate a new equation. All right, so we are going to actually go back to my average velocity and my average acceleration. Let's see what order they gave me these in. Okay, well, we're not going to start there. So hopefully we know this particular equation right here. This is my average acceleration, right? Average acceleration. I take my velocity final minus my initial over how much time it took me to do that, right? On your quiz, you had going from 60 to 80 miles an hour, whatever, subtract, divide by the total number of seconds it took you to do that, right? And so that's what we're finding when we're finding average acceleration. So we're going to start there. All right. What we're going to try to do is we're going to try to get this little group by itself. So if I want to get that by itself, I'm just going to multiply both sides by change in time. All right. So far, so good. Now, here's the thing. We're going to go back to our equation that we had when we were working through it, manipulating these particular functions. This is what they get. They get my, another way to write displacement is going to be initial velocity times time, 1/2 acceleration times the time squared. And so that's one of them right there. Now, here's the thing. I want to find my final velocity. I want to find my final velocity, my final position. So I'm going to do some more manipulation. I'm going to use this guy right here, and I'm going to replace some things. So I'm going to replace this, and I'm going to keep this, and I'm going to replace this. I'm going to take this whole thing right here, and I'm going to replace it there. So we got this from how we solved for it. We're going to replace all of it. I'm going to say, well, to find my final position, I need my initial position. I need my initial velocity and my time, my acceleration and my time. This equation comes from these two. It comes from this one. That's just my average position. And it comes from manipulating all of these to replace this guy. All right, so we have my final. This should be on your worksheet, your handout. My final is my initial plus my velocity times time, 1/2 acceleration times squared. 1/2 acceleration times squared. Two is we are going to take our average velocity times our change in time. All right, we get that from average acceleration. All right, average acceleration. So what you'll notice is this and this are the same, correct? So we're going to use substitution. We're going to take this and we're going to plug it in there. So I have my change in x equals my initial velocity times my time plus 1/2. And I'm replacing that with my average acceleration times time times change in time. All right. Nope, we're going to get to it. I just want to show you where it comes from. All right. So I have change in time times change in time. How do you think I can write that? If I had like a times a, how would you write that? A squared. So that's how I'm going to write it. I'm going to say 1/2 average acceleration times change in time squared. All right? This is another way you can write that position. And so, all right, so there will be times when it creates a quadratic. Not always, but sometimes. The second equation, your independent variable is your change in time. Your dependent, what you're solving for, is your final position. You have some constants in there. So your acceleration, your average acceleration is going to be a constant. Your initial position is going to be a constant, and your initial velocity is going to be a constant in that equation. All right? And so when we set these up, that's kind of what can happen there. It's a quadratic because if you think about it, position can be two places. Like if I were to throw a ball up, there could be two places that it would be at the same position, on its way up and on its way down. And so sometimes it's a quadratic because there's potentially two different areas. Not always, but sometimes. All right, position over time. Position over time then, and you don't have a graph yet, but we're going to go through some. You have to think about that my time is changing while my position is changing. Even though this is sloped, remember my acceleration is going to be the slope of the tangent line at any one point of the tangent line, because I have to go from position to velocity to acceleration. And so you can graph the time to position or you can graph the time to acceleration. It just depends on what they want you to graph.